Hello friends, good morning. Myself Dr. M.A. Channaya, and in this video we are going to work out a problem on the section of a square pyramid which is cut by a section plane which is normal to VP and inclined at 40 degrees to HP, and the solid is resting on its base on HP with all the four base edges equally inclined to VP. That is, this base edge, say AB and this is AD, they are equally inclined. And the same problem can also be given as the two of the base edges are equally inclined to VP, that's at 45 degrees to VP. Or all the four edges equally inclined to VP. So friends, I am going to construct this square of the given side of 30 millimeter such that every side of the base is perpendicular to is equally inclined to VP. That is at an angle of 45 degrees. You can say 45, 45 both the sides. And friends, let us mark the pyramid as A, B, C, D. A, B, C and D represents the four corners of the base, and we can transfer all these points and the corners to the front view and obtain O dash, A dash here, B dash, D dash, along with the point O1 dash, this is C dash. Friends, the height of the solid is given to be 65 mm. So I will just construct this front view taking O dash at a height of 65 millimeter from the base. And is telling that it is cut by a section plane which is normal to VP, inclined at 45 degrees to HP, and we have to add passing through one of the base corners, corners of the base. There are four corners A, B, C, and D. It is passing through one of the corners. Now friends, if you observe the front view, A dash is one of the corners, C dash is the other corner. So you can take the section plane inclined this way or to this way. So as it has to be at an angle of 40 degrees to HP. So friends, through this point A dash, I am going to draw a section plane SS which is at an angle of 40 degrees to HP. That means this angle, whatever you are getting here, is at an angle of 40 degrees to HP, and very obviously it is perpendicular to VP. So we have placed the object, we have got the front view and top view, and also we have located the positions where the section plane is cutting this solid. So the section plane is cutting or passing through the corner A, cutting the slant edges OB and OD at this point, and again this at point some other OC is cut here. So basically you are going to have 4 points in this section. So friends, after this is cut by the section plane, generally the upper portion is removed, and whatever the portion that is left over has to be shown by visible lines. So this is the portion that is retained. Now friends, this is the front view of the solid we have got, and let us see how it looks in the top view along with the section. Friends, let us take this point as 1, and 1 can be marked at this point, let's say 1. And here OC is cut at this point, so on OC we are going to mark this point. So this is going to be one of the points. And friends, OB and OD are also cut here. And to locate that, since we are drawing the sectional end view also, we can project this. And before that, let me mark this. This is D double dash. This line is A double dash, C double dash, and this is B double dash. O double dash is the vertex in the end view, and O1 double dash is the base or center of the base. Friends, OB and OD are cut here, so you can just write a horizontal line from there till it cuts OB and also this point OD. Finally, this point was easier. Now friends, if we have the end view, you can get the point here, or if we have the top view, front view and end view, you can locate that point. So friends, OD is cut here. Write a vertical line from there till it cuts the 45-degree line and locate that point on OD. Similarly, on the other end, you can mark this OB and the same procedure. You will get this OD at the point here at the equal distance. O to this is equal to O to this. They are the same. Friends, we have got all the 4 points on the 4 slant edges of the solid. That is, this is 1. If I call this B as 2, this is 3, and this point is 4. We have got all the 4 points. We will join them by straight line and section it. So I am going to join 1 to 2 by a straight line, 2 to 3 by a straight line, 3 to 4 another straight line, finally 4 to 1. We have joined all these. So we will hatch it or section it by writing lines at an angle of 45 degrees to the horizontal. And friends, apart from this portion, we have got these edges which are remaining, that has to be shown by dark lines or visible lines. And this is how the solid appears in the top view when it's cut by the section plane. And friends, we will call this as sectional top view, STV. So it is asked in the question, front view you have got sectional top view. This is sectional top view you have also got. And then we have to draw the sectional end view. Friends, let's see what are the points. The end view you have got here. 1 is at A, 2 is on OB, 4 is on OD, and I have to get this point on OC. That's going to be point 3. We have got all the 4 points marked in the end view. So let us join them on the same lines by full lines or visible lines. Say 3 to 4, 2 to 3, 1 to 4, and then 1 to 2. We have got all these 4 points, friends. The complete base ABCD is retained. So let me darken that. And the portion from 2 to P is retained, that you can see in the front view. 4 to D is also retained. And friends, here you will observe we have got all these 4 points in the end view. And let me join and hatch this by lines drawn at 45 degrees to the horizontal. Friends, the portion above this, that is to say this is 1, this is 2, 4, this point is 3, we have marked. 3 should come on this, 2 and 4 here, 1 on this. Friends, this view you have got here is called sectional end view, SEV, or left sectional end view. So that is SEV or left sectional end view. This is the sectional top view. And finally, we need to obtain the true shape of the section. Friends, it's very obvious that in the true shape of the section also, we need to get, or we have to get 4 points only. So what is the procedure to draw the true shape of the section? You know very well, friends. you have the section plane here, cutting the solid at 4 points on the slant edges. So we will draw a line parallel to this SS at any convenient distance away from the section plane. And from all these points, namely 1, 2, 3, and 4, we will draw perpendicular lines. We will draw perpendicular lines like this, and all these lines are perpendicular to this. Now, above this line, which is drawn parallel to this, we have to locate the points 1, 2, 3, and 4. Friends, please look at the board. 1 is here at this much distance on this. So I am going to mark point 1 here, whatever the distance you have got. Say this is point number 1. Then on this, you have got 4 at this distance. So we will call this as point number 4. On this same line, you have got point 2 at a distance of so much from that line. So friends, we are going to have this line extended and mark that point on that. Finally friends, we have this point 3. So distance of 3 comes exactly in between these two. So this is 1, point number 2, point 3, and this is point 4. So we need to join all these points by straight lines. So 2 to 1, a straight line, 1 to 4, straight line, 3 to 4, and 2 to 3. Friends, this is how the 4 points appear, and we have to section this again by drawing lines at 45 degrees to the horizontal, and this figure will represent the true shape TS, true shape of this section. Friends, I hope you are able to follow the instructions to obtain the front view, sectional top view, sectional end view, and true shape of the section when the square pyramid resting on its base with two of the base edges equally inclined to VP and is cut by a section plane which is passing through one of the corners of the base and inclined at an angle of 40 degrees to HP. Friends, please go through the complete video without skipping anything in between or any part of this video in between. And if you like this video, friends, please share the information of this video with all your friends and have a wonderful day. This is Dr. M.H. Annaya signing off.